All right, we did not get a chance to meet during our first week of distance learning, so I wanted to still post a video for you to go over some factoring review. So when we left school, we were finishing up factoring, and we had one more section of that unit to go over. So in this video, I'd like to review the different types of factoring that we did, and then quickly present the final thing from Unit 7. So, if you'll remember, when we were factoring before we left, we always had to check to see if we had a GCF. That was the first thing that we always looked for. Once we did that, we could determine whether we were looking at a polynomial with 2 terms, 3 terms, or 4 terms, and that determined how we would factor our polynomial. So we're going to look at each of these individually. So a 2-term polynomial, we checked to see if we were looking at a difference of squares. So a difference of squares is a perfect square minus another perfect square. If we have that, then we can factor in the form a plus b times a minus b, which is the square root of the first term and the square root of the second term separated by plus and minus sign. So in my first example here, I do have a perfect square minus another perfect square. So I'm going to ask myself, what is the square root of x squared? Square root of x squared is x. And what is the square root of 64? Square root of 64 is 8. And I'm going to separate those by a plus and a minus sign. So this can be factored into x plus 8 times x minus 8. In the second example, we must take out a GCF first. So I can take out a 2n. If I take out a 2n, I'm left with 9m squared minus n squared. What I'm left with is a difference of squares. A perfect square minus a perfect square. So I am not done factoring this polynomial. So I still have my 2n out in front. And then what's the square root of 9m squared? Well, that's 3m. And what's the square root of n squared? Just n. And I separate them with a plus and a minus sign. So those are 2-term polynomials. Now, be careful because, for example, if we had x squared plus 64, this is not factorable because we don't have a subtraction sign separating those perfect squares. It only works with difference of squares. All right, let's continue. So then next one we're looking at is a 3-term polynomial. And in this case, it is a trinomial, and the leading coefficient here is a 1. When you have a 1 as your leading coefficient, you're asking what multiplies to c and adds to b. So I'm looking for 2 numbers that when multiplied will give me c, the coefficient, and when added together will give me b. So, for example, in number 1 here, I have 1 as my leading coefficient. There's no GCF to take out. So I'm asking what multiplies to negative 42 and adds to negative 1? That would be negative 7 and positive 6. So I could break up that polynomial into x minus 7 times x plus 6. In my second example, I have a GCF that needs to come out before I can do anything else. So I need to take out a 2. When I take out a 2, I'm left with w squared plus 10w plus 25. Now I have a 1 as my leading coefficient, so I can ask what multiplies to 25 and adds to 10. Well, those factors would be 5 and 5. So I can factor that into 2 times w plus 5 times w plus 5. We can rewrite that since the w plus 5 is a repeated factor. We can just write 2 times w plus 5 squared. Okay, we're going to move on to 4 terms. Four-term polynomials are factored by grouping. We're looking at our first group of 2 terms and our second group of 2 terms separately. We're going to take the GCF from each of those groups. So let me rewrite that over here. So from my first group, it looks like I can take out an a squared as my GCF. And I would be left with 2a minus b. Now, I want to get that same 2a minus b from this second group of 2 terms. And in order to have gotten that, I had to take out a positive 5 as the GCF. So my final factored form is the common factor, 2a minus b, and the GCFs put together, a squared plus 5. We're going to use this factoring by grouping as we go back to our trinomials that do not have a 1 as the leading coefficient. So in this case, this a means that it's not a 1, okay? It's some number other than 1. So we're going to factor that by a method called split the middle. Now, what I notice about this trinomial is that first we need to take out a GCF. I'm just going to rewrite it up here. So I can take out a 3, and I'm left with 10x squared minus 9x plus 2. Now, instead of asking what multiplies to 2 and adds to negative 9, because it's not a 1 here, I'm going to ask what multiplies to 20, multiplying that 10 times the 2, and adds to negative 9. That would be negative 5 and negative 4. Now, what I'm going to do is I'm going to rewrite this trinomial, but I'm going to replace the middle term. I'm going to split that negative 9x into negative 5x and negative 4x. So I have 3, and I'm going to use a bracket here because I'm going to have more parentheses later. So I'm just going to split the middle now. So I have 10x squared minus 5x minus 4x. That took the place of the negative 9x. And then plus 2 stays the same. Now I have 4 terms in these brackets. So I'm going to factor that just like the slide before. I'm going to factor by grouping. So I first want to look at the first 2 terms, pull out the GCF. Then I look at the last 2 terms and pull out the GCF. So I still have that 3 outside. The greatest common factor of my first group would be 5x. If I pull out 5x, I'm left with 2x minus 1. Remember, I want to get the same factor from that second group. In order to do that, I had to pull out a negative 2. So my final factored form is the 3, the common factor, 2x minus 1, and then the GCFs put together, 5x and negative 2. And that's my final factored form. Now we had one more small topic to cover. when we did not return to school. And that is dividing a polynomial by a binomial. Now, earlier in the unit, we divided polynomials by a monomial. So for example, we saw things like 6x cubed plus 3x squared plus 9 divided by 3. And we said that we could just divide the denominator into each term of the numerator. So for example, 6x cubed divided by 3 is 2x cubed. Then second term, 3x squared divided by 3 is x squared. And then the last term, 9 divided by 3 is just 3. Now, what's different in this scenario is that we're not dividing by a monomial like we were here. We're dividing by a binomial, and you cannot split up that binomial. So how we take care of this division is we factor the numerator. That's our first step. So in this case, I'm asking what multiplies to -8 and adds to +7. Well, that would be -1 and +8. So I can rewrite the numerator as x plus 8 times x minus 1. And I still have my x minus 1 in the denominator. The next step says I can cancel out any common factors. So I have an x minus 1 in my numerator and an x minus 1 in my denominator. So they're gone. So my final answer is just what is remaining, which is the x plus 8. So not too difficult. Hopefully this video helps, and hopefully I will see you week 2 of distance learning. See you then.